All right. The next problem that we're going to do, number 67 this is, and it says if 4.5 grams, so we have a mass, 4.5 grams, is that correct? Of methane. Methane is CH4, that's methane. Yes? Okay, the simplest of the hydrocarbon alkanes. Is in a 2-liter container. 2-liter container. So now we have a volume of 2 liters. Yes? Is in a 2-liter container at 35 degrees Celsius. So now we have a temperature 35 degrees Celsius. Automatically change that to Kelvin. What do you got? 308, that's correct. 308 Kelvin. Okay? Next. It's asking for the pressure in the container. And you said it, I didn't. What law are you using? Ideal gas law, right? And the ideal gas equation is, do you remember?
E times G equal N times R times T.
That's right. P V equals nRT. Somebody look up for me R. It's in the book. You can do it. Somebody look up R.
31.
What is it?
8.31.
8.31. And in case you don't know what it is and you're doing work, I'm going to show you how to calculate it, okay? It's easy. Okay. So, now, I'm looking for this, P, right? So can we solve for that? Is that good? Is that all right? What can I do to N, though? N is moles. But isn't that grams over gram molecular weight? Right? So let me change this. Grams over gram molecular weight. Okay? Yes? Okay? So what does that mean? So, well, let me move this down a little bit. Can I erase something here? No, I'll work right here. All right, so the P equals what? What's the mass? 4.5. What's the mass of 1 mole of methane? Anybody? What's the mass of 1 mole of methane? What is it? 16. 12 plus 4 is 16. Right? That's the moles. That's N. Right? That's N. R is 8.31. We're going to forget about the unit labels for R just for a second. Yes or no?
Yeah.
There's somebody in there?
No.
No? Okay, good. Okay, so T, not that T, is going to be 308 Kelvin over what? Is that on? Let's just move this a little bit over this way. Over what?
2.
Over 2. Good. Anybody have an answer for that? So what you'd say is 4.5 divided by 16. What's that equal?
That's equal to 0.28.
All right, so 0.28 times 8.31, that's R, times 308 divided by 2.
That is 358.3.
358. So the pressure equals 358, what? Kilopascals.
Kilopascals.
You know, is that right? I mean, can you check in the back? Is there an answer in the back? Somebody want to check? Check for us? I always love to check the answers to see if I did it right, you know? I've been doing these same problems for years. I still like to check, just to see it in print, that I can actually predict it. What number is this? 67?
Yeah.
So it's 360 kilopascals.
3.
360. So it's just round off error. do you see how it's set up top? Do you see they give you a little bit of a, same thing we did, right? 0.28, right? You get it? I think they said 0.281. That might have been the difference. Yes, Aiden. That's okay. That's round off error. You know, it's okay. For a problem like this, where the meat of the answer is over here, if you said 9 or 6.0, that would be fine. If you said 258, that's, sorry. But yeah, round off error. I'm the judge, but, you know, certain things make sense to me. I've been doing this for so long. I know I could predict even what kind of round off error it is. I could predict whether or not you kept the whole thing in your calculator. Sometimes students calculate this individually. Maybe they'll say 0.28. Like maybe some of you did that. You know, some of you kept everything in your calculator. I don't know what you did. But that's certainly within the right ballpark. Now, what happens if you don't know R? What is R? How do I calculate R? How do I calculate R? Wouldn't I say R equals what? PV over NT? Right? Wouldn't I say that? Yes or no? Is that right or not? Right? Now remember, R is calculated at STP. Okay? So at STP, what's P? 101.3 kilopascals. What's V? 22.4. And what is 22.4? You were very quick to say that the volume is 22.4. But in reality, what quantity is 22.4? Anybody know? One what?
1 mole.
Yeah, 1 mole. You know, you're saying it like you're kind of guessing. I mean, where else would you get 22.4? When you see the volume, 22.4, don't you automatically think mole? 1 mole of any gas at STP is going to have a volume of 22.4 liters, right? So it's going to be 1 mole. And then what's temperature? STP, 0 degrees Celsius. What's the temperature? What is it? No. Come on. What is it? 373? 273. Actually, you could bring that out 5 significant figures, but we don't care. Now, right now, calculate this. 101.3 times 22.4 divided by 1. You don't really have to do that. Divided by 273. But every time you hit divided by, every time you go into the denominator, you have to hit divided by unless you put parentheses around the entire denominator. What do you get? You get, surprise, surprise, 8.31. And it's going to be kilopascals, liters over mole, Kelvin. You get it? That's how you calculate R if you had to. Okay? Easy?
But it's going to be always 8.31.
It's going to be 8.31. Why is it going to be 8.31? I haven't always used 8.31. Why is it going to be 8.31? Because you're using kilopascals. You're using liters. You're using Kelvin. You're using mole. I haven't always used kilopascals. You know, it used to be more standard in the chemistry course to use 1 atmosphere. That's going to give you a different R, isn't it? Right? Okay? All right, enough said. So now let's do another problem. I'll turn this off, and we'll do one more problem, and then we'll quit for the day. Okay?